In this video, we're going to introduce limits and how to evaluate them. So first of all, why do we care about limits? Well, we might be faced up with a function that might have some an issue or two along the way. So for example, it might be undefined at some value or another, but we still can find out how the function behaves near that value. So what we're going to start out with is a function over here that you can see on the screen right now. And so let's just see first what happens when we graph this function. So I've already drawn my graph over here, and you can see just over here, this is my function. And you'll notice that when this comes into a graphing calculator like that, it immediately becomes a linear graph. Okay, so that's all good and fine. You might look at the function at first and think, well, this doesn't look like a linear function at all. I mean, we've got an x squared in here, and then we're dividing by x and stuff like that. But just for the sake of this example here, we're just going to say, okay, this here turns out to be a straight line or a linear graph. Now, if you have very keen eyes, then you might see that what we have over here is we're taking some small function and we're dividing that by x minus 3. Well, in that case, what would happen if x had the value 3? So if x equals 3, what would happen then? Well, in the top we would have x squared, so 3 squared minus 9. That's going to give me 0. And then over here, we're going to have x, so 3 minus 3 is also 0. Then what we would have is a situation of where we have a fraction where we've got 0 divided by 0, which is something that we obviously cannot have. We can never divide any function by 0, including the number 0. So you might be really tempted to say, well, 0 divided by 0, that's 0 divided by itself. You might be tempted to say that's 1, but that's really not what we're allowed to do, at least not in the maths world. So then how do we know how the function behaves at x equals 3, and why then do we have all of the numbers here? So you can see here when x is equal to 3, then we do have a number, right? We seem to have the number x equals 3 evaluates to 6. So how can that possibly be? And what we can do is we can see what the function behaves like as the value x approaches 3. And we have special notation for that. For that, we're investigating the limit, so lim, as x approaches 3 of our function f of x. And we can either say, if we've defined this function before, we can just reference it here again, or we can just take this entire thing and say this again. So that's x squared minus 9 over x minus 3. What would that mean? Well, there's a couple of ways that we can do it without necessarily looking at a graph. And I'll show you one of those examples now. So one method, method 1 that you could use is substitute values of x that are really, really close to 3. Okay, so substitute values close to 3. So for example, one value we might substitute is x equals to 2.999. You can see that's obviously really close to 3. Or x equals to 3.001. Both of those values are incredibly close to 0 without being equal to 3. And we can see how that makes a difference, or how that shows us what it approaches. So let's go ahead and do that. So let's substitute in f evaluated at 2.999. What would that look like? Well, that would be then 2.999 squared minus 9 divided by 2.999 minus 3. What would that be? And again, for that you can just use your calculator to do the heavy lifting for you. 2.999 squared minus 9. Okay, you can see that gives me some number, and I divide that by 2.999 minus 3. And that gives me a number of 5.999. So in other words, a value that is really, really close to 6. Cool, so far so good. What would happen if we substituted the other value? What would happen if we substituted f of 3.001? Well, that would be 3.001 squared minus 9, all divided by 3.001 minus 3. And what would that do? So let's type in those numbers into our calculator. So 3.001 squared minus 3, that gives me a number, divided by 3.001 minus 3. And from there you can see that gives me the number 6.001. So if we do it like this, then we can be sure that from here the limit as my x value approaches 3, so we can say therefore limit as x approaches 3, my function x squared minus 9 divided by x minus 3 is equal to 6. Now, this value is not actually included on the graph. And if we draw the graph a little bit more carefully, like this, then this is how we would have to draw that function, because we need to say very clearly that this function is not defined at this point. So right, so just because of that fact, so that's why we put a point on there, like a hollow dot, just to say we are not including that value. Okay. Now, from here, we're going to have another look at how else we could define, or how else we could find out what the limit is as x approaches 3. So here is method 2. So we've got f of x, again, equals to x squared minus 9 divided by x minus 3. So method 2. And for some cases, method 1 will be more useful. For some cases, method 2 will be more useful. I'll show you why method 2 might not always be that easy to use. But so here we've got, right, so we can take our function and we can rewrite our function in this way. Again, if you've taken a close look at the function that we're dealing with, you might be able to see that we can actually factorize this top part, which turns out to be x plus 3 times x minus 3, all divided by x minus 3. And you're looking at this, and your first instinct might be to say, aha, I can see x minus 3 over here, divided by x minus 3. What I can just do is I can just simplify that to say, well, these two here, these two terms, they cancel out. And technically you would be correct. You could then write this as x plus 3, like that. But you need to still keep in mind that you are excluding x equals 3. Okay, so x is not equal to 3. Okay, so we just need to be a little bit careful with that, because otherwise, again, we are dividing by 0, which is obviously not allowed. So this is what our function would then simplify to. And finding out how our function behaves when x has the value or is near the value 3, then from here it becomes much easier to see, right? Because now we can say, well, limit as x approaches 3, my function x plus 3 is just going to be 6, right? Because you can say, you can just evaluate this function here at x equals to 3. Then that would be 3 plus 3, that gives you 6. But again, of course, you must be careful and must mention that x cannot actually be 3 because we are dividing by it. We are only investigating how the function behaves near that value of x.